Hello everyone. In this video, we'll be seeing how to simplify Boolean functions using one of the reduction technique called K-map or Karnaugh map. Okay, also stands for Karnaugh map. So to begin with, we'll see what are the different types of K-maps we have. How do we map or how do we draw the K-maps for different number of variables? So to start, we'll start with the first one, that is two variable K-map. Okay, so two variable K-map is, I have two input variables. I'll call them as A and B, right? And if I have two variables, I can have four different combinations, that is power of 2. So 2 to the power 2 variables, 2 power n, where n stands for number of variables. Okay, so since I have two variables in this example, I'll get four combinations, binary combinations. And those four binary combinations are, it can be 0, 0, 0, 1, 1, 0, 1, 1, right? Now I have to draw the K-map in such a way that I will be having cells for these four combinations. So since I have two variables, one of the variable will be mapped to the row A, another variable will be mapped to the column, that is B. So K-map is like a matrix, okay? So you have rows as well as columns. So two variables, one variable will be mapped to the row, another variable will be mapped to column, right? So I'm taking A as corresponding to row number and B will be corresponding to the column. So one variable can have two possible values, either 0 or 1. Similarly, B can have two possible values. It can be either 0 or a 1. Now I have to write the numbers inside these boxes, or we call this as cell. One box is nothing but one cell. So what will be the value for this? Now you know that when you have two variables, you have four combinations. And in decimal, if I have to write this number, 0, 0 means decimal 0. 0, 1 means it is decimal number 1. 1, 0 is 2. 1, 1 is 3. So I need to write these numbers in these cells. Okay. Now if I look at the first box, the combination row value is 0, column value is 0. So it is 0, 0 combination. So this box will be number 0. Now for the second box, the row number is 0, column number is 1. So 0, 1. 0, 1 means this box will be 1. For the third box, row is 1, column is 0. So 1, 0 means 2. And for the last box, it is 1, 1. This is nothing but 3. So this becomes the K-map if you have only two variables in the given question. Then you can simplify. I'll talk about the simplification once you know how to write the diagram for this. Okay, I hope this is clear now. If you have two variables, you'll have four combinations, that is 0, 1, 2, and 3. So you need 4 cells so that all these four numbers can be written here. And for two variables, one variable will be assigned to row, another variable will be assigned to column. So next we'll go to three variable K. So similarly, you can pause the video and you can try to map and then check if you have got it correctly. Okay. So in three variable, you have three inputs. So 2 to the power n. So 2 power 3, which means you will have 8 combinations in binary, starting from all zeros, ending at all ones, right? So 0, 0, 0. Next combination is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 5, 6, and this will be 7. So in decimal, if I have to write the numbers, this is 0, 1, 2, 3, 4, 5, 6, and 7. So which means you need 8 boxes so that you can write these 8 numbers. How do I arrange it? Now I have three variables, right? I can split it into two parts. I'll keep one variable on the row side. Okay. So if I keep one variable on the row side, I'll keep only A. So one variable can take only two values, either 0 or 1. So you have two rows. So if you have two rows, you have to now include a number of columns such a way that totally you will get 8 boxes. So two rows are there. I need 8 boxes, which means I have to divide this into 4 parts. Then I will get 1, 2, 3, 4, 5, 6, 7, 8. Total 8 cell. Okay, so I've kept one variable here, which can take either a 0 or a 1. Remaining two variables I'll put on the column side. And when you have two variables, it can take four possible combinations. That is, your B and C can be 0, 0, 0, 1, 1, 0, or 1, 1. Okay, so if you have two variables, four possibilities are there. So I'll write the possibility 0, 0. It can be 0, 1. Now remember, when you're writing K-map, it follows something called gray code. Okay, so it follows something called gray code method, which means from one value to the next value, there cannot be a change in more than one positions. So just look at these two numbers. When I'm going from 0, 0 to 0, 1, there is a change happening in only the least LSP position. Next, after 0, 1, it is supposed to be 1, 0. But if I write this, you can see there is a change happening in two positions. One is changing to 0 and this 0 is changing to 1. This is not allowed in gray code thing. So I cannot follow this while writing the K-map. Instead of going from 0, 1 to 1, 0, I'll go to 1, 1 after 0, 1. So here you can see there is only one position changing. That's why when you're writing K-map, the order changes here. Okay, so first two will be same, 0, 0, 0, 1, and the next two are going to be interchanged. Because from here to here, from one box to the other box, there should be change happening in only one position. Okay, so this is how you write the K-map for three variables. So this is very important, one very important step here. Okay, whenever you're writing the combination for the column, make sure that there is a change happening in only one position. It should follow the gray code method. So now once you have written this, now I can put the numbers inside the box. So for the first box, the value is 0, 0, 0, which means it is 0. Now for the second box, the row is 0, column is 0, 1. So when I read it together, 0, 0, 1. 0, 0, 1 is nothing but decimal number 1. Now for the third box, it is 0, 1, 1. 0, 1, 1 is 3. So this box will be 3. Next is 0, 1, 0. 0, 1, 0 is similarly for the lower one, row is 1, columns are 0, 0. So 1, 0, 0 means 4 in decimal. 1, 0, 1, 5. 1, 1, 1 is 7. 1, 1, 0 will be 6. So once you write this, no, this remains same for any K-map you take. Three variable K-map, this numbering does not change. Okay, this order will never change for any three variable K-map. Similarly, for two variable K-map, it is always going to be 0, 1, 2, 3. Here it is 0, 1, 3, 2, 4, 5, 7, 6. This order is fixed for all problems. Okay, so this is three variable K-map. Now coming to the next one, that is four variable. So now you have 2 power 4, which means total 16 combinations will be there. So I have to take 4 input variables A, B, C, D. Then I'll have 16 combinations. Then comes 0, 1, 0, 0, 0, 1, 0, 1. So 6. This will be 7. Then 1, 0, 0, 0, 8, 9, 10, 11, 12, 13, 14, and 15. So decimal numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So I have to now arrange this matrix or the table in such a form that I should be getting total 16 boxes so that I can put these 16 numbers. And since I have four variables, I need to assign some of them to row and some of them to columns, right? I'll divide them equally. Okay, I'll take two variables for row and remaining two variables for column. So if I have two variables, then I can get four combinations, right? So I will be having four rows and four columns because two variables are there. So I'll have four rows and four columns. Now, again, while writing the combination, remember the gray code part. So starting with 0, 0, 0, 1, the third number is going to be 1, 1, and then 1, 0. Same thing follows for this also. 0, 0, 0, 1, 1, 1, 1. Okay, this is very crucial here. Please don't make a mistake here. If you write 1, 0, then last 1, 1, you are going to get a wrong answer for this. Only in K-map, the gray code needs to be followed properly. So now, based upon the values in the row and column, you can write the numbers inside the box. So this is all 0 for the first one, so this will be 0. Then this is 0, 0, 0, 1, it is 1. 0, 0, 1, 1, 3. 0, 0, 1, 0 is 2. Similarly, 0, 1, 0, 0 is 4. And 0, 1, 0, 1 is 5. Then this will be 7, 6. Here it is 1, 1, 0, 0. 1, 1, 0, 0 here is nothing but 12. So here we'll be having 12. 1, 1, 0, 1 will be 13, 15, and this is 14. 1, 0, 0, 0 is 8, 9, 11, 10. So it will be easy to remember 0, 1, 3, 2. Or you can just remember 0, 1, 2, 3, 4, 5, 6, and 7. Jump, one jump in the end. And then 8, 9, 11, 10 comes in the lower part. Above that you have 12, 13, 15, and 14. So this is the K-map for 4 variable, which is going to be fixed for all types of problems. Any problem you solve, this numbering order does not change. Okay, so this is how you would draw the K-map for 2 variable, 3 variable, and 4 variable. So in your syllabus, maximum, they're going to ask only for 3 and 4. 2 variables are usually not asked. And 5 variable can also be done, but it's very complex, and you'll have to use 2 4 variable K maps side by side and then solve it. Okay, but your syllabus they have given only 4 variables, so we'll be stopping for this part. Now in this, before we start off with solving the problems, there is one more important concept you need to know, that is called what is prime implicant, one more is essential prime implicant. Okay. So I'll just take one small example here. Let's see how to group. I'm taking an example of 3 variable K-map. Let's say they've given you a question, a function f of ABC, which is equal to summation m, and I'll take the numbers as 3, 5, 6, and 7. Okay. So this is a question given, and they're asking you to simplify this particular given function. So you know summation m stands for SOP, where min terms are given. So if SOP equation is given and they're asking you to simplify it, which means in the K-map, first we'll write the K-map for 3 variable, okay? Since it's given as ABC, A will be here and BC will be on the column side. So A can take 2 values, 0 or 1, and BC can take 4 combinations, so 0, 0, 0, 1, but here it is 1, 1, and then 1, 0. Accordingly, we know the cell numbers 0, 1, 2, 3, 4, 5, here 6, and then 7. Now, one more thing you need to remember is writing the variable for these binary combinations. If it is 0, it means it is A bar. If it is 1, it is the value as it is. Similarly, here you have 0, 0, which means this will be B bar, C bar. This one will be B bar, C. This is BC, and this is BC bar. Okay. If it is a 0, write the variable in complement form. If it is a 1, write the variable in uncomplemented form. Right? Now, whenever a SOP equation is given, you're supposed to place the numbers, whichever number is mentioned in the question, no? Inside those boxes, you have to put a 1. Okay, so whenever SOP equation is given, you have to put ones in the box numbers mentioned in the question. So here they're given 3, 5, 6, and 7. So the first box will be 3, then you have 5, 6, and 7. Remaining boxes, you can forget about it. If I don't put anything, it is either assumed to be 0 or don't care. Okay, so whichever box is mentioned, we have to put ones in those boxes for summation m or SOP format, minterm or SOP. Next step is to group them. You have to make groups. And the group should be always in powers of 2. Either it can be 2 power 0, which is 1, or it can be 2 power 1, which is 2, 2 power 2, 4, 2 power 3, 8. Either you can group a single cell, or you can pair two cells, or you can take a quad. This is quad, this is pair, this is single, and this will be octet, where 8 cells are grouped as one. Okay. So you just have to look. You cannot take odd number of cells and group them. Okay. And grouping can be done such that if I have a 1 in this position and 1 in this position, I can take these two as one adjacent. Okay. Corner ones. If I have a map like this, and I have ones here in these 4 places, I can group them as a quad, 4 cells in one group. The corners can be grouped together. Or if I have something like this, and I have ones here, then I can make these as one thing. Okay. But in case you have a cell like this, one here and one here, I cannot group these as quad. I cannot join these 4 cells into one group. They should be next to each other, or they can be in the corner like this. Because you can just imagine if I fold this to cover it, like when I fold this as a sheet, and if these two corners are touching each other, then it means that these two corners are next to each other, right? When I fold it. So that's why I can group the corners together, or they should be next to each other like this. If there is a gap between them, then I cannot take it as a group. Okay. In that case, these two are next to each other, they become pair. Since these two are next to each other, they become a pair. Okay. Similarly, if I have one and one here, there's one here. These two are next to each other, so they become pair. They can be grouped together. But this one you see, it doesn't have any other one next to it, adjacent to it. So this becomes a single. Okay, so this is single. This is pair. If I have one more one here, since it has an opportunity to group with this, I can group it. So it's a pair. But this one does not have any adjacent ones. So this cannot be grouped with anything. It becomes a single then. Okay. So this is how you group in 3 ways. So maximum possible value you can get is octet. Octet can happen only when you have all ones, and this can be completely grouped as one. But in 3 variable, octet will not be given to you. Maximum you can get is quad. That is 4 ones. So whenever you're grouping in K-map, you have to always start with a higher number. First is octet. Since octet is not possible, most of the problems will not be getting octet. Look for quads. See if any 4 ones are there next to each other like this, either in corners or in the middle like this, or it can be somewhere here also, or it can be like this also, right? So you have to look for the quad. Or it can be like you have all ones in one of the rows. It can be grouped in this way also. Okay. So look for quad. If quad is not there, the second option is look for pairs. Any 2 numbers together. Any 2 cells adjacent to each other. If that is also not possible, only then you go for single. Okay. So always start with 4 cells, then look for 2 cell, and then single. Okay. Now for the given problem, I will just randomly write one example here. 0, 1, 2, 3, 4, 5, 6, 7. This is A, this is BC, 0, 0, 0, 1, 1, 1, 1, 0. This will be A bar and A. 0, 0 means B bar, C bar. This will be B bar, C bar, B, C, B, C bar. Okay. Now let's assume that I have these two here. Then there is one single here. Now I want to make a group. So this is the problem given. Now when you're grouping, look for the higher number. Octet is not possible because you don't have all ones, all 8 ones. So next higher number will be quad. So quad means 4 ones together. So here you have a quad option. So I'll group it as one group. Okay. Then you have search, you have one more one to be covered. You should cover all the ones. That is the condition. No ones should be left out. So these four ones are done. Now we have one cell that is left out. It cannot be grouped with these four together. But this is in the corner, and you have one in the corner. So I can group it with this single cell and make it a pair. Okay, since these two are in the corners, I can group them into one pair. Okay, I'm not grouping this cell number 2 with this entire quad. I'm grouping the cell number 2 only with the value that is there in cell number 0. So this becomes a pair. Okay, now how do we write the equation for this? So the first group quad equation is check if all the rows are, whichever rows are covered. Now, for this quad, you have both the rows are covered, and you have to see which variable is common in the two rows. So you don't have common. In the first row, it is a bar, second row, it is a. If I add a plus a bar, it becomes 1. Okay, which means if the variable is changing, I don't have to write it. You can eliminate that variable. Now look at the columns. This quad is covering the column number 1 and 2. So in this two column, you have B bar, C bar in one column, B bar, C in another column. Out of the two, which variable is constant? Only that variable will be written. Okay. So here B bar is common in both of them. So write only that variable. C bar is changing to C in the next one, so that gets cancelled. Okay. So I'll repeat again. If I take the row numbers, you don't have a common variable, so don't write it. When I look at the columns, B bar is common in both the columns, so I'll write only B bar. So this becomes the answer for the first group. Okay. Similarly, for the second group, I have to write the equation. So second group is a pair between cell number 0 and cell number 2. So this group corresponds to the row number A bar. So it will be A bar. It cannot change. It is only one row, right? It does not have, you cannot look for the change happening because it is covering only one row. So if it is covering only one of the row or one of the column, write that value as it is without eliminating. So here it is A bar. Now look at the columns. Column number 0 and column number 2 here. Between these two numbers, these two variables, you see which one is fixed, which is not changing. So C bar is not changing, so that will be written. So you have to write which does not change. Okay. So finally you have the answer as A bar C bar for the second group. Now simplified answer should be written like this. F of ABC is equal to whatever answers you're getting, no, for each group, just add them or operation. Okay. B bar plus A bar C bar. This will be your answer. This is your SOP equation. Okay. So whenever after simplifying the K-map, you have to just or all the answers. That is add them. Binary additional. So hope this is clear. Whenever you're solving free variable K-map, the first thing to remember is the order in which you write the numbers inside the K-map. Second thing is always start with a higher number group. Look for octet, then for quad, then pair, and then single. All possible ways you have to see if it can be paired. You should remember corners can be paired to each other. Okay, okay. And then for each group that you have made, you have to write the equations. And the condition to write the equation is whichever variable does not change, which is fixed, that variable should be retained. Which variable changes, you have to eliminate it. And once you get the equations for all the groups, just add them and write at the final equation. Okay. So this is how we solve three variable K-map. Now in this example that I have mentioned earlier, I'll just explain some keywords, key terminologies. If you remember, I had taken an example that I had written once in these cases, right? So now we can see if I have to group them, I have different possible ways of grouping this right now. So to cover this one, I have an adjacent one in cell number 7, so I can pair them. I cannot make a group of 3. Odd number is not allowed here. Only a single is possible, or else a pair, or quad, or 8. So it's always in powers of 2. Okay. odd number is not possible. So this one I have to cover with the help of this group. Now to cover cell number 6, I'll have to group it like this. And to cover cell number 1 or cell number 3, this one, I'll need a 1 here. Okay. I'll write one more 1 in this place. And to cover this one, either I can go for a quad or I can just cover it again. So this is what I have. Let's take this example to be more clear. So here, now to cover this one, I can pair it like this. To cover this one, I can pair it like this. And you might think you can pair these two ones also because they are adjacent, right? So you may end up doing this also, right? Now, I'll explain about 3 keywords here. The first keyword is implicant. What do we mean by implicant? Implicant means the equation or the min term of every cell, individual cell is called as implicant. If I take this cell, you have A bar, you have B bar, C bar, B bar C, B C, B C bar is A. What is the equation for the first cell? It is A bar, B bar, C bar. This is called as implicant. Similarly, here you have A bar, B bar, C. This is also an implicant. So individual cell terms what you have, no? All of them are called as implicants. The second one is prime implicant or PI. Prime implicant means what are the possible ways in which you can group them? All those possible group equations are called prime implicants. Okay. So, but prime implicant always starts with a higher number. If that is already covered in a quad, then again don't consider it as, don't take it for some other pairing. Okay. So, prime implicant is all possible ways of grouping. Those group equations will come under prime implicant. Now, here if I've taken 3 possible ways of grouping them. No? So, the first group equation is going to be, since it has only one row, A, 2 columns where C is fixed. So, this equation becomes AC. Now, for this group, the row is A bar, the columns B is fixed, so it becomes A bar. But, and for this, it is taking both the rows and A is changing, so A will not be written. Only one column will be there, that is BC. So all these equations, AC, BC, and A bar B, all these 3 are prime implicants because we have 3 possible ways of grouping them. Okay. The last term is essential fragment. Or I. So what is essential prime implicant? It is also a prime implicant, but which is essential in nature. Now, if you look at the 3 groups, the first group, to cover this one, you don't have any other way to cover it other than this pairing, which means this becomes very much essential. Without this group, you cannot cover this one here. Similarly, if I want to cover the one in cell number 2, this group becomes very important. Without this, I cannot cover. So this also becomes essential. Coming to the third one, cell number 3 and cell number 7 are already covered using the other 2. So covering them again is not required. So this is not essential. It's a dummy term that you are getting because these 2 ones are already there in a pair with someone else. So you don't have to pair it separately. So this is not essential. Okay. So now under essential prime implicants, you will be having only AC and A bar B. BC will not be essential. So your final answer will be just AC plus A bar B. You don't have to take this dummy term because it's already covered. Okay. So the essential prime implicant meaning is that group should have at least one cell which is not covered in any other group. So if I look at this group, there is one cell which is not covered in any other group. It is a part of, or it is unique only to this group. Similarly, this one cannot be covered with any other group. It is a unique number for this. Okay, so essential prime implicants are groups which have at least one cell which is unique to that group, which is not covered in any other group. Okay, so this is the concept of implicate, prime implicate, essential prime implicate. So there might be questions where they will give you a function and ask you to simplify it using K-map and also list all the prime and essential prime implicates. So in that case, you have to know what is the number of prime and essential prime. Prime is all possible uh, ways of grouping them that equation can be written. Essential prime is those groups which have at least one unique cell not covered in any other group that will come under essential prime implicate. Okay, so we'll stop here. In the next lecture video, I'll talk about how to solve four variable K maps.